Energy yield of glycolysis. So before we understand the energy yield of glycolysis, it is better to revisit the two phases of glycolysis from the energetics point of view. Number one is energy investment phase, and number two is energy generation phase. In the energy investment phase, there is an investment of ATP in two reactions. Number one is phosphorylation of glucose. One molecule of ATP is invested. And second is phosphorylation of fructose 6-phosphate. One more ATP molecule is invested. So the total energy invested in the energy investment phase is 2 molecules of ATP. Similarly, in the energy generation phase, there is generation of ATP or NADH in 3 reactions. In oxidation of glyceraldehyde 3-phosphate, 1 NADH is generated. In synthesis of 3-phosphoglycerate, 1 more molecule of ATP is generated. And in formation of pyruvate, another ATP is generated. And we know that 2 molecules of glyceraldehyde 3-phosphate enter into the subsequent steps of glycolysis, starting from 1 molecule of glucose. So the total energy generated will be double the energy from each of the products which are generated after the reactions of glyceraldehyde 3-phosphate onwards. So the total energy generated equals to 2 times NADH, 1 ATP and 1 ATP. So 2 NADH and 4 ATP molecules will be generated in the energy generation phase. Now before we give a final touch to the energy yield of glycolysis, let's revisit the concept of type of glycolysis as anaerobic and aerobic glycolysis. In anaerobic glycolysis, the total energy yield, which is equal to the energy generated minus energy invested, is very simple. That is 4 ATP minus 2 ATP, that is 2 ATP. The NADH generated is not used to provide any energy in the anaerobic glycolysis, but it is used to continue the glycolysis. Whereas in the aerobic glycolysis, the total energy yielded, which is again equal to energy generated minus energy invested, is a function of not only the overall ATP molecules but also of the NADH. Now since 2 NADH molecules are generated, the energy equivalence of 2 NADH, if this NADH donates electron to the electron transport chain, which is followed by oxidative phosphorylation to produce ATP, from 1 NADH molecule 2.5 ATP molecules can be generated. So from 2 NADH molecules 5 ATPs will be generated. So the 2 ATPs which are extra come from the ATPs difference between energy generated and energy invested. So the total ATP will be 7 molecules of ATP. Now in aerobic glycolysis, the total ATP in the normal scenario will be 7 molecules of ATP. But actually it is either 5 ATP or 6 ATP or 7 ATP, which is based on how the 2 molecules of NADH are shuttled into the mitochondria and utilized in the oxidative phosphorylation. So what it means is there are 2 subtle pathways which are operated for this transfer of cytosolic NADH, because NADH, this NADH is formed in the cytosol as a result of glycolysis, and the oxidative phosphorylation takes place in the mitochondria. Now for this NADH to be utilized to generate energy, it has to enter into the mitochondrial matrix first and then can donate electron to the electron transport chain. Now there are 2 pathways for entry of this NADH into the mitochondrial matrix, and based on these 2 pathways the NADH will be having different energy values. Now the different subtle pathways will be discussed in later classes, but as a result of 2 different subtle pathways, the 2 NADH after entering into the mitochondrial matrix will be able to donate electrons, and the energy generated will be either 5 ATPs or 6 ATPs or 7 ATPs, where this 2 ATP will always be constant, and the number of ATP that can be generated from NADH will be different. NADH in fact always has 2.5 ATP equivalents, but NADH based on the subtle pathway will either be entering into the mitochondrial matrix in the form of NADH itself or another reduced coenzyme form, that is FADS2. Now if it enters in the form of FADS2, its energy equivalent becomes 1.5 ATP. Now if both NADH enters in the form of FADS2, the total ATP will be 1.5 into 2, that is 3 plus 2, 5 ATP. If one NADH enters as NADH, another NADH enters as FADS2, then total ATP will be 1.5 plus 2.5, that is 4 ATP plus 2 ATP, that is 6 ATP. If both the NADH enter as the NADH into the mitochondrial matrix, then the energy equivalent will be 2.5 into 2 plus 2, that is 7 ATP. Now this either 5, 6 or 7 ATPs, it depends upon the subtle pathway, and subsequently depends on whether NADH, cytosolic NADH is presented to the mitochondria in the form of either NADH or FADS2, and which entirely depends upon the type of the subtle system.